Let us find the velocity of the projectile at any instant. Again, let me draw the diagram. Horizontal line, vertical line. Okay, so let's say this is the x, that's the y-axis, and this is point O. Let me use this scale once again. Yeah, make it smaller. Okay, so let's say the body reaches this point at any instant. Okay, that point P, let's say. All right, so what will be the you should remember that that is the direction which the body is going. So at this point, what will be the direction of the velocity of the body? Okay, so let the velocity be v. All right, and we know that velocity is always tangential. Okay, so the velocity of the body will be along the tangent. All right, let me redraw this nicely. I think let me use no problem. So the velocity will be in that direction. Okay, so this will be v bar. Got it? Now what we do is we using this as the diagonal, we are going to construct a parallelogram. Let me take this one there. So this component will be Vx and this component will be Vy. Understand? And let the velocity make an angle beta with the horizontal. Okay, so what is V? V is the velocity of the body when it reaches point P. And then resolving V, we get along the horizontal Vx and along the vertical Vy. Okay, right. So let us use this formula. V is equal to U plus AT. Okay, so again, along the horizontal, you get Vx is equal to Ux plus AX T, right? But then we know that AX is 0 and UX is what? I think by now we are very familiar with UX. UX is nothing but U cos theta. Okay, let's call this some equation 1. Since AX is 0, there is no acceleration along the horizontal. And along the vertical Vy, this will be Uy plus AY t. So Vy is what? Uy is U sine theta. Okay, and theta is what? Theta is this, the angle of projection. AY is minus G. All right, so you need to give this as equation 2. Now, therefore, since this is a right-angled triangle, isn't it? Vx and Vy are making an angle 90 degrees. So therefore, this will simply be Vx square plus Vy square under root. Okay, so this is from the theory of vectors. All right. Then let us put Vx and Vy from equation 1 and equation 2. So Vx square here will be U square cos square theta plus U sine theta minus gt whole thing square under a root. So U square cos square theta, let us apply the a minus b whole thing square formula. You will get a U square sine square theta plus a square plus b square minus 2ab. So g square t square minus 2ab 2ugt sine theta. Okay, that will be under the root. Got it? But then here, u square cos square theta and u square sine square theta, I can take common u square. Inside of the bracket, you will have cos square theta plus sine square theta, which is equal to 1. So you are left with u square plus g square t square minus 2u gt sine theta. This is the expression of the magnitude of the velocity at any instant. Let me put this inside of a box. Okay, now this is the magnitude. How do we know the direction? To know the direction, we need to find this angle beta. Okay, so let me just write here. I hope I have enough space. So how do you find this angle beta? Let us take tan beta. Tan beta is perpendicular by base. So this is the perpendicular, and this perpendicular is nothing but this one. So this will be Vy, not Vy bar, right? Because angle is just the length of this perpendicular. Got it? Divided by the length of this base, Vx. Okay, and what is Vy out there? U sine theta minus gt divided by Vx is u cos theta. So this implies tan beta is equal to, of course, I can divide this first. So u and u will cancel. I will get tan theta minus gt by u cos theta. Got it? So if I know the value of the terms on the right hand side, I will be able to find the angle theta. So this gives the direction of the velocity at any instant of time